You know what? I'm just going to start it from here. Live.
For future reference?
Thanks. Okay, I'm starting from here, I think. Yeah, it's live now.
But it's not live on my screen.
I think it is now.
Oh, it is?
Just reload it. Should be good.
That's weird. I see myself on a delay on the top one.
Yeah, there's definitely...
This says preview.
Oh, okay.
If you go to the user view down there. Yeah, it's working.
Oh, it's working.
Oh, okay.
Cool.
Okay, so I think we're going to get started if that's okay with everyone. Are there two presentations or?
Yeah, I was going to speak.
I do. It looks like we have food, so I guess we'll wait a second. You know.
Pasta with
Wow, that's fantastic. Incredible.
jalapeno and cabbage.
The live stream's gonna have to wait for everyone to get pasta.
Here's how much pasta we have.
Is everyone okay with being live streamed and recorded?
Yeah, everyone here is gonna be recorded. Like everything you say is gonna be recorded in live stream. Where are you aiming?
It's going to be just pointing right that way?
The audio. Right?
Audio, yeah.
Okay.
But you can just not say anything until we stop it.
Okay.
Don't say your private key out loud.
That's slowly reading your private key.
Okay, you're okay with Creative Commons, right?
Yeah.
Cool.
Yeah. That's for my man.
Okay, I'm out of here.
Thanks for
Just
saying.
leave it. I'll get it when I get back.
Okay, thanks.
Should we turn off or anything when we're done?
When you want to stop the stream, just press this
Red button.
It'll-
I can remember that. Thanks. All right, I guess I'll start. So I'm going to talk about streams, but I feel that a lot of people may have ideas about what a stream is, so I wanted to start because I think it's easier if you compare it to the familiar concept of a variable. So if you have a variable, call it x, we call it 3, how do we describe the way this variable changes over time? What's a way of describing the way it changes over time? We don't really have one, right? We just basically change it when we want it to be something new. So if we think about it, if we look at it the right way, we can have something where it's like, let's say we have a timeline, now we change it to something else. That's confusing because this is called x. So I'll make an O for whenever we change the value of the variable. So now we have another value here, another value here, and this is time, right? So do we understand this is a timeline, right? So we have a bunch of different values actually, and they change, but how do we relate the different values that happen over time together? So that's really what the value of a stream is. You can think of a stream as this timeline. Rather than the individual values, it represents a series of values over time. So to make this more concrete, I have a whole litany of examples. This is one. So we're using a module called Kefir, or Kefir. I don't know how you pronounce that, but I assume it's like the Kefir. Okay, let's go with Kefir. That's the most authoritative answer I've heard, so call it Kefir. So Kefir implements this idea of a stream, and we can get into the nitty-gritties of what it actually means, but basically you turn a bunch of events into a single stream, right? The events are the O's in this last figure over here, and the stream is the whole timeline. So when we have key presses, what does this look like? Well, let's log our key stream using this handy log feature that they have. And by the way, I'm using Watchify to build this. You can see I have requirements for events in a browser. If you don't know what Watchify is, there was a great presentation earlier in CyberWizard, so I'm sure you can look it up and find internet resources. All right, so here's some web page. Don't worry about what's on there, but we're logging the key stream. Oh man. Let me restart this and see. Oh. Okay, but we're logging the key stream, and you can see whenever I press a button, something shows up here. And it's the key code and so on, right? So with just this one thing, we see it's kind of like console.logging something that doesn't really show what it means that it's over time, right? So let's make that a little more clear. Let's turn this into a stream of characters. So we make something called char stream that takes the key stream, and maps a function over it. Every function, every event that comes through, we turn it into the string that its char code represents. So let's now log this char string. I bet you can guess what's going to happen. It's nothing too crazy. It's just going to log the character that I pressed, right? Okay, but this still doesn't really show what's happening over time. So what is going on?
Yeah, so it's very nonprofit.
So let's make a string stream. The string stream takes a function with an accumulator and a current value. This is kind of like a reduce if you're familiar with that concept. But the really important part, the high level thing you need to know is that when we're processing the stream, we only look at one thing at a time. We go one element at a time and we accrue it in this thing called an accumulator, and we have this current function, and we do this process to the accumulator as we go through the stream until it's over. So in this case, we add a string onto the stream. So can anyone guess what's going to happen here? When I press buttons,
it's going to output the character that you pressed, like a string that grows every time you press the character.
Exactly. Let me start watchify in case something needs to be working. Oh no, it's because I didn't log in. Okay. Man, how do many people make this? Alright, so we log in. As predicted, we get a stream of values over time. So this is interesting because now we're really only processing one thing at a time, or so it seems, right? We have this very simple notion of a key stream, and suddenly we can build this larger thing that like more describes what's happening over a period of time, right? All right, so we can make this slightly more complicated. In this one, we make what's called a left stream, what I'm calling a left stream and a right stream. Basically, we're filtering the press stream, which is the same as it was before, all the key down events, by certain key values that they represent. In this case, it's my left arrow and my right arrow, right? Whenever a left arrow comes through, we map it to the number -1. Whenever a right key press comes in, we map it to the function 1. And now we can create a position stream, right? This is the position of this circle in the browser. So how do we create this position stream? Well, we have this left stream and this right stream. So what we can do is merge them into a single stream, left stream and right stream, right? And then we can use this thing called scan, which is the same thing you saw earlier. It takes an accumulator and a current value, and it adds them together. And then this value that comes after that is the value that we want to start at, so 50. So what we have is we have a value that starts at 50. Every time something comes in where we press the right button, we add 1 to 50. Every time something comes in, we press the left button, right? And this happens over time. So now we have this idea called a side effect. So what's different about this one from every other thing that appears on the screen? What's different about this last little expression? It doesn't return anything, right? Like all these other things start with the word var. They start with the keyword var. They assign some value to something else. This one doesn't do that. It's called a side effect. It just takes some input and then magic happens and we don't see anything back. So this happens all the time, and side effects are interesting, but for our purpose they're really interesting because it's usually related to the thing we actually want to do. So we take the position stream, and whenever a value happens, we do a function on that position where we move the dot. Okay? So let's see what that looks like. It's going to be exactly as you expect. The dot moves when I press the button, and this could have been done in any other way, so you probably still don't understand why this is cool. But let's see a little more, and maybe you'll start to get the idea. Okay, so this may look confusing because why my functions all in one line, etc. It's crazy, right? But let's see here. This is the part of the program that matters. So just look here and don't worry about the rest. This is why streams, at least in the front end, are really interesting, because you can describe what the program is doing in a really almost like English language way, right? Our left stream is the press stream filtered by the left key and mapped onto -1. Our right stream is the press stream filtered by the right key and mapped onto 1. The position of the dot is merging these two streams and scanning their sum, starting at 50. And now we can do a whole bunch of side effects, right? So the one we saw earlier is this top one where we move the dot, right? But I was thinking about maybe a crossfader. If you're doing like a DJ application or something like that, then you can set the left gain also, right, by using the dot position. So we can see how that works. Up here, we have this like left gain function. And again, it just takes the position as input. And the right gain function does the same, except it works in a slightly different way. So we can watch this, refresh our page, maybe fit. now, essentially, we can see the right and left track volumes change over time. So why is this cool? I say it's cool because you can describe this without getting involved with the details of how all these functions work. And you can write these functions that work in a really obvious way. It's really obvious how this works. I remember some people were talking about currying the other day. So you were talking about currying? Someone else, you were talking about currying. Yeah, so we do a bit of currying here. You can see we make this function called key filter that takes an event in a key code. And if it's the key code, we give back the event. Now we can make a more specific function by currying in a specific key code, right? We curry in the key code for the left and the key code for the right, and now we have another really simple function. And we can compose these functions by sending our streams through them, and we get an application. And I think that's a nice thing. So why would you actually want to do this in the real world? I decided to do one more example where you can see doing a post request to a server, because that might make a little more sense. So I have this thing that I got through my work. It's like this breath sensor that sits in your waistband, and it has an accelerometer on it where you can, when you inhale, it registers the inhales and exhales throughout the day and like stores them in the cloud somewhere. You can access this through an API. So I was like, okay, well, good thing for a demo. So what I wanted to do is I select a date, and I see all my breathing over the day. So I'll show you what it looks like. I select this random date, fetch my breathing data, and we get this nice graph of all my breathing. Button, I can press my button and get a stream of click events, right? So how do these two fit together, right? I want, whenever I click the button, to get the stream, so it's like I have these two streams, how do I make them relate to each other? Well, I take my date selector event, that's the stream of every time I change the date, and I sample it by the button click stream. I sample it, does that make sense? It's like plugging it in at a certain time. Stream by some other stream. So whenever I click, we get the current or whatever the most recent date selection was. And then I map this raw jQuery event using this simple function up here to its value as date. Again, this is just something that's built into the HTML date selector thing. So what I return is this nice stream of dates, and they come in every time I click the button. So now remember back here, what I was doing was I was feeding this date selection stream to my cool graph. So let's see my cool graph. Again, we just skip down to the bottom to see what's going on. We do some garbage involving writing it to the HTML page, but that's not interesting. What's interesting is I get my breath stream, my stream of breath data, by taking my date stream and flat mapping it. This is a little like mapping it, let's say, to this API response stream. So let's look at the API response stream before we go any further. What we have here is an AJAX request, and we get a stream of responses. I make a request to this URL, and what I get back is a stream of responses. Another way of thinking that you may be familiar with is promise. It's kind of like a promise, but what you can see is basically promises, they can do whatever they want. They can have this thing called success, they can have this thing called fail, sometimes it's called error, you don't know what it's called, right? Streams have two things. They have something you push over it and an error. So you can emit an error or you can emit a value. That's the only thing you can do. So I try to map promises onto that here. I emit, whenever it's done, I emit that data. Whenever it fails, I emit an error. That's simple enough. And then we take one value, and after that value comes in, and that's the end of the story. So we query the thing, we get back a response stream. So if you're not sufficiently confused now, every time we get a date stream, we make a brand new stream. So what do? We use this thing called flatmap. Flatmap takes a stream, takes the values in the stream, and puts it back into the original stream. So what we have is, if you're familiar with list processing at all, if you put a list or like an array inside an array, and you flatten the array, what you get is one flat array where all the elements in the inner array were taken and moved into the outer array. That's the same thing that's going on here. We have one stream, then we have another stream inside that stream, then we take that stream and merge it, flat map it into the original. So now we have a breath stream. This is a stream of responses from the API. We map to this raw API response something called time series, which just takes the data. Now we have a list of data. And then the final thing we do is render the data on the value. So again, with a little bit of hurrying, we can write this function render that takes data and uses this draw graph thing we defined up here and maps through every piece of data and appends it to the thing. So once again, you can see how this works. I pick my day, my magical day where I know I have data, and I calculate it and we get some value. You won't see it change because it's the only day I have data. But again, let's go through this quickly. So if there's one thing you learned today, there's one thing you learned. It's that a stream is some value that represents a bunch of values over time, at least in the functional reactive sense. That's what a stream is. And why you might want to do that is because you can describe what your program's doing in these really simple declarative ways. Basically, you write a setup function, and that describes the way it is going to behave through time. So we have this date selector that returns a stream of date selections. We feed the stream of date selections into the graph, and now we have like a pipe. You can describe as a pipeline how this works. And then the only thing we do to run the program is that when the document is ready, we run the setup.
So, but we put a pipe inside a pipe. When did you put the stream? You mapped it inside to another stream?
Right. So
what
I
streams are you
did
dealing
that.
with? And why?
Sorry.
What streams you're dealing with again? And
Right.
Right.
Okay. So I put a stream inside a stream when I wanted to get. So what came in from one stream is a stream of dates. You get a list of dates. Dates come in over time. I get a date. I get a date. Okay. Every time I get a date, what do I do with it? I grab the date. And now I have a URL that I want to make an API request to. So I make an API request to the URL, that's fine, but I have no idea when this API request is going to respond. The server can take as long as it wants. It could take 30 seconds, it could take a minute, who knows. So how do I represent that? I represent it maybe as a stream, right? I say, okay, the stream represents all the values I might get back. I might get back one value, I might get back 5 values, no idea when they're going to come in, but I can describe the stream of things that are going to come through it, right? So what I get back is the stream of potential responses to the API back where I had my dates. And now with the stream, I say, okay, whenever something does come through, I take the thing that comes out of it and put it back into this pipeline where the dates were. And now I have, instead of a list of dates at the end where I have this ref stream, at this point in the pipeline, I have a list of responses from the API, which are breath rates. And then I map those over some functions, and then I render the things that, in mapping, this is just to make it easy to render, and the render is obviously the side effect function I was talking about sooner. It doesn't return anything. It just draws it. So that's all I had. If anyone has any questions, happy to answer them. And if you have that distant look in your eyes, then maybe your mind is sufficiently warped by the idea of the stream.
Do you have the code online?
I do have the code online. That's a good
put it-
question.
yeah,
I should definitely send that link.
Yeah. So we'll have that on the site.
Yeah, is there a place I should put that? I'll just write the URL up here. GitHub, else how, and the repository is called Streams for the Damned.
Yeah, he has the code.
Here it is.
Nick. Oh, else.
Else how up here. Yeah, so all the code is here. We have a little explanation, and yeah, the thing we were just looking at is a larger application. It's called Spire, so you can look through that if you want. And there's this little bash script called build.sh. You can just run that if you want to build a bundle.
Do you use streams with things that weren't dates, like audio or video?
Oh, for sure. I have an example, in fact, of doing it with audio if you're interested. So one cool use of the stream, I'm sorry, you have to remind me your name? Leslie. Okay, one thing, Nick. So one thing Leslie pointed out is that, okay, here's a game I made a while ago. Some of you may remember it. It's a game where you shout into your microphone, and everyone else is also shouting into your microphone, and the loudest person shouting, their car goes the fastest in a race. Okay, so that's all well and good. It's a fun game. I'm not going to set it up now. The important part is
The solitaire deal.
yes, the important part is that you get a solitaire win screen when you win. So we have this thing here. Now this is in CoffeeScript, which is something I deeply regret, and I can't take it back. You're gonna have to live with it. I'll try to highlight the important parts. So we get a microphone from this magical NPM module called Audio Context that works in every browser for reasons I don't understand. It uses dark magic, but what happens is you can create an analyzer. We get this thing called an analyzer, whatever. Yeah, absolutely. Also, I'm sorry there's no syntax highlighting here. It's because I'm, maybe if I just show it in GitHub, it'll be easier for everyone. Much better. All right, so we get the access to microphone, get the user's audio, and now we get a stream of microphone amplitudes. So that's a little magical. How does the stream of microphone amplitudes work? Well, we get this analyzer. This is a web audio thing, and we give the stream that we get. Now this is confusing. This is a different stream. This is a different kind of stream. This is the kind of stream that your browser assigns to microphone data. But we have to turn it into the kind of stream we can use. So we do that with this thing called average amplitude stream. Well, what I was interested in, obviously, was getting the volume, right? How loud are you shouting? So we operationalized that with the amplitude of the audio buffer at every given time. I used some dark magic that you are free to copy if you are to do a thing with microphone data. And every time our buffer fills up, we get the average volume of our buffer, and we push it on through the stream. So how do we use it in the game? Well, when we get the amplitude stream back as a callback from this microphone manager thing, we ask the person to join the conversation or join the game or whatever. They pick a color, we call back on the color, and now we have this publish thing where we publish it to a subpub, pub subsystem. You can use a free one like WebSockets if you want. Oh, sorry, I have a bot that generates gradients, so you can just watch this gradient with my laptop. And then while the events come in, so we get another stream back. I can show you quickly how this works. It's called event stream. It's pretty simple. We get a stream back from, so I use this service called Pusher. It's just SaaS. I don't know. It's closed source. It's kind of the worst, but you know, I can turn it into a stream. It's the important part. We get a stream of events that come in from this Pusher thing, and back in this guy, we can map them to the car positions of our cars on the screen. So that's cool. We have a stream of amplitudes coming in from the microphone. We do some magic with them, and we can turn them back into something that comes out as a side effect UI operation. Okay, nice. If you guys have any questions, there's some great things out there. Again, this module I was using is called Kefir. If you Google Kefir, not the drink, you'll find it. Also, if you Google
Did you, okay, so we stopped this one, right?
Okay.
This one. Do you know how we started it yet?
I don't know. I'm just going to press.
So
I have this little thing. I put a screen inside of it.
I don't know if we're
That's
seeing it
not-
though. You might
Right,
look
smart
at the
apps, and I
screen.
put the screen, put it all here.
So what's
I don't even know what it's
So the advantage of that, instead of saying,
and I can go live now, right?
so if I didn't do this, what I would end up is this situation.
Would you have to wait for
You're late.
So,
That was
It's
lazy.
more of a programming here. I might.
Looks like
So
You good on
if
that,
I
Kim?
didn't do this, I would end up with
okay, so,
Okay.
how do you, oh, is it live?
I said it's a preview. I can set it to live if you want.
Well, because I have it's like what
No, I set it to live just now.
Text to get size. People in the back.
whereas if I just say
It's a preview right now.
Could I
Is text a
put
good
it,
size? Can you actually read it? Because
I want to take it to
a little
a
small.
video. I
It's a
just
little
put
good.
it in
Oh,
Markdown.
okay. Let me stop this one.
So I have a new event called Markdown.
Okay. Stop.
Jalapenos are not a spicy pepper. I have one.
Oh, that's fine.
Leslie like once she lived in.
Your seat by your
I mean, maybe just close the other one. Or just close. Don't look at it.
Yeah, you can come this way too.
I don't know. They have like.
One time I ate
It's just live right now. So
But I want to put it on the.
we can move stuff around later.
Oh.
Don't worry about it. Starts from me. Also share the link in the RC channel.
Oh, I did.
Oh, okay.
I just want it on this one. I guess we could just put it all in one.
Yeah, whatever.
Yeah, I think I just my computer went to sleep. Is there actually a good way to turn that off?
That's what you get for teaching others.
This is wonderful though. Thanks for bringing it.
Oh yeah, I think that was. Could be. So you want to flat out.
Let me know when I'm good to go.
Either way, it's pretty funny. You want to flatten out some stuff.
Do you know how to stop the stream once it's started? I just wanted to do
Yeah.
The stream is really weird. Like apparently it's very difficult to do in that interface. We spent like an hour trying to figure it out.
I think
Don't stop the stream. Just keep it going.
Oh, just keep it going.
Live stream lifestyle.
Live stream. Live stream.
Okay, live stream. How do I start it again? Do I just press it?
I don't know. Did you
This
know
is
that
so
if
hard
you
to
stop
use.
the camera?
There's a magic box. Oh, it's live.
Yeah.
This one's working.
In the YouTube interface, there's like literally not something.
That's bizarre.
It's like one thing said to just turn off your browser.
That's not what.
No, it's live now. It's live now. Sorry.
okay, it's good to go.
Okay.
Okay, I guess I'll start then. Hi everyone, my name is Tyler. I was hoping to give a speech today called Intro to Using Streams. It's really intended for someone who has never used a stream before, but is sort of familiar with the terminal and bash and maybe hasn't installed Node, but hasn't really used it a lot. I wanted to give some answers, some okay answers to questions like what is a stream, why I use streams, and how do I use streams. And so to start it off, what is a stream? I think streams can be defined in many different contexts and in many different ways, but I think a unifying concept is that it's the idea that programs that modify data should have a standard interface for communicating with each other. And another core to streams is that data is passed as it is retrieved. So when you have a program that is modifying its data, as it accesses the data, it should pass it on as soon as it has it. It shouldn't wait for more data to come, even if you're expecting it. So it should pass it as soon as it has it. Directly from that is like, you can kind of answer some common use cases for why you would want to use streams. It makes it really easy for your program to be used by other programs without having to do much work. You're using a standard interface, so any other program that also uses it, you can use it now too, and it can be used by, they can use you as well. It encourages you to design small programs that do one thing well. James gave really good reason for why that is actually an excellent design philosophy in general in his previous speech. You get to separate concerns of your program, and you kind of, because of that, you reduce the overall complexity of your code because you have a lot of small programs that do one thing well. And streams are also used in many different languages and actually in a lot of different contexts. So if you can understand some of the concepts that underlie them, you can go to many different situations and have the ability to understand what's going on, even if you don't know the specific details of what is happening in this specific scenario. And I think it also helps to have some kind of visualization of what a stream is and how it works. And I think James gave a really good one, so I pretty much directly took it from his previous speech. The garden hose is actually a really good visualization of what a stream is. So the quote goes, we should have some ways of connecting programs like a garden hose. Screw in another segment when it becomes necessary to massage data in another way. And I think that that's also might be where a lot of like the water analogies come in. When people are talking about streams in specific scenarios and in abstract ones, they use like a lot of water analogies. And I think that the garden hose really gives like a good visualization for what's happening when you're passing data between programs. You can imagine like your program as a water hose, and it might have a lot of like bends and loops and do a ton of stuff, but it still has a common end to it that you can then screw on to another person's garden hose, and the data, or like the water data, will just flow right through it, and so you can just pass things along in a really nice way. So that might still be a little bit confused. So I have a few experiments that we can like run through and get a little bit better understanding of what it means to actually use a stream and like how they work. And so I have some examples here using Bash, just to start us off, because I think it's where a lot of people started using streams was actually in Bash, especially in their terminal. So the first thing, if you want to follow along, you can type it into your computer too. You can type the commands ls space pipe, or the vertical bar, space grep x, where x is like a part of a file name in your current directory. I'll do it here so you can see what it looks like in my computer. So when I type this thing, text shows up on the screen. So if you have no idea what those commands do, I kind of lay it down. The utility ls is a program that lists files in the current directory, and it usually just outputs the files in your directory right out onto the screen. The utility grep finds files, like it does a lot of stuff, but one of the things it does is it finds files that match the pattern of the text to the right of the word grep. So like for me, when I did grep.js, it went and found all of the files that had JS in it. And the pipe, or vertical bar, is will take the output of the program on the left and use it as the input of the program on the right. Like flow of events, where ls, the program ls, outputs the list of files in your current directory. Then the pipe takes that output and puts it into the input of grep. Grep does its thing where it finds all the files that match the pattern, and then it finally returns control back to you and puts the text onto the screen for you. And what's really nifty about that is that pipe is a stream. Pipe is a stream, and it's really nifty that ls and grep were designed completely separately of each other, but they both work with data, but they didn't know about each other. And pipe is this magical keyword almost that takes the data that those two things output and input and is able to just like feed it into the other one magically. So that was pretty interesting, and that's like the very first, I think, example a lot of people have when they're working with streams for the very first time. And so I have another experiment that I like to use when trying to understand a bit more of like what's going on behind that magical pipe thing that just was able to feed in the output of one program into the other one. And so this other experiment, I'm gonna not explain too in depth exactly how I set it up. You're just gonna have to trust me on this one. But first, what you can do is you can create a named pipe using the utility make_vfo. And so what that looks like is it's over here. You can do make_vfo mypipe. I just gave it a name, mypipe. And what this is kind of interesting is that it actually, you can see here mypipe, it's even highlighted in my terminal, and it allows you to actually create a named pipe. So we can actually, instead of just using vertical bar, which may or may not do this behind the scenes, which is kind of just magical, it's just like this keyword that works, you now get to see a pipe like kind of on your file system almost. So you get to kind of like poke around at it a bit more.
Sorry, what's the make_vfo command?
The make_vfo command is it's a utility that makes VFOs.
What's a FIFO?
It's a data structure. It's first in, first out is the idea. So it kind of works like a pipe in that the first data that goes in first is put out first. And it kind of gives you this, the output of it kind of gives you this magical file thing called that.
So it's like a list of things, like a queue.
It's a queue.
Yeah.
It's a queue, yeah. But it kind of gives you this magical file that exists on your file system now that works just like the vertical bar, but it now exists as a file. And you can kind of see when you ls-l, you can see here like where it, like there's the normal file permissions even, but it has this special p, meaning pipe. So you can see it's a pipe. It's like literally just like you like named the vertical bar something else. So it's kind of interesting because you get to kind of poke around at what is happening when you use the vertical bar, and so you get to kind of understand streams as they are in Bash a little bit better. And so one interesting thing you can do is actually use, instead of using the vertical bar, you can actually pass data into this named pipe and then listen to it and see what happens. So how you can do that is by typing, for example, ls-l, and then pass that data, that's what the caret means, pass that, the output of that command into my pipe. And you can see here my terminal is not, the control to my terminal is not being passed back to me, it's just hanging. And it's, we can stop that hanging, before I explain exactly what's happening. Before we can stop that hanging by listening to my pipe. So you can see here in a completely different terminal, I was able to reference the named pipe, and the data that came from this terminal session over here, passed that data into my pipe, and then listened for it on a completely different terminal session, and the data was transferred. And that's kind of interesting because it kind of gives you a little bit more of a feeling for what's happening with the vertical bar. The vertical, like when you are using a pipe, you pass the output of ls-l goes into my pipe, and it hangs and is waiting for someone to pick up on the other end of the phone almost. Like someone's calling and it's just like ringing, 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 waiting for someone to be listening. And then once someone hooks on, Cat hooks on to my pipe and picks up the phone almost. And then the data goes through. So that's like another important concept too, I think, is that sometimes in streams you'll need to guarantee to the stream that there will be a listener. And so that's kind of an example of what's called blocking. But I won't go too much into that. But I think that's a pretty standard thing in streams that you'll hear a lot, is like that it blocks the process. It won't return control back to your terminal, for example, in this case, until someone picks up the phone and listens. And then it passes all that data through, and then it can finally call it a day. It can be done.
So it's blocking, which means it's synchronous operation?
I think asynchronous and synchronous have like, I've been a little bit confused by it, and it changes depending on the context. I found, and I don't know exactly how synchronicity works with Bash in the terminal. But it,
well, you said it's blocking code, right? So it makes things wait for it before it continues?
Yeah.
With the script? Code isn't blocking.
Code's not blocking, it's that the node program, actually the LS program is not terminating until, I guess, all scripters are cleaned up.
Until when?
That LS is not terminating until, I guess, until it has an open file scripter.
I think that is exactly what's happening. But I wasn't too sure where file descriptors came into this. I could have done more research on that. But yeah, it is just waiting for, the program doesn't terminate, just like you say, until someone else retrieves data from the pipe. And so in that sense, it's blocking. Like you saw in my terminal, when I did ls and then forwarded the data to my pipe, it just hung. Like I can't do anything else but send data to the pipe. And it's only until someone else listens.
Wait until and a file character will be in. But I'm not really sure.
What's that?
I think you do like control D in my index.
Oh yeah, there's ways to terminate it. Yeah, you can like cancel early what's happening. And I'm not sure exactly how that affects the pipe, which would actually be interesting. But yeah, there are ways to exit processes. It's like a force quit for an application. Is that what you mean to say?
Yeah, I don't really know. Well, there's also in cloud character, which might do it, but I'm not really sure.
Oh, okay, I see what you're saying. So it doesn't, okay. Yeah, so you can just like send data to the pipe and then something will eventually come along and listen to it?
In the file is a particular byte in the string.
Oh, I see what you're saying. So like, okay. Well, should we demo that or? Okay.
So Tyler, I wonder if you go back to that example
This one?
where you created the MyPipe and you
Okay.
the ls.l.
Mm-hmm.
I wonder if anything's actually moving until you get a receiver on the other side and the cat receives MyPipe.
I have that question too.
Yeah.
Like when I subscribe, does that mean stuff comes from the beginning all the way through, or is it hanging somewhere in that character, you know, between LSL and my pipe?
That's
until it's
interesting.
subscribed?
I think he
I'll
kind of
bet
had
there's
it.
nothing until you invoke it.
And then it just runs the whole thing
Precisely.
through.
Yeah.
I think that's might have been what he was talking about with the end of file thing, and that might have cleared it up for us. So maybe let's try the Control D. So like he might have been saying like if you do this and then Control D, which sends an end of file. No.
Yeah, if we subscribe to my pipe now, will we still see something?
Well, I don't know if Control D did that.
Maybe Control C or something like that.
Yeah, just end it.
And just end the process. Yeah, now can we still get that thing out of my pipe?
No.
No. So
No,
it probably
so it
runs
does
all the way
wait
through.
the whole time. So it needs a listener before it will fully, like it needs like the connection to be fully present before it.
Before it does anything.
Question.
Good
That's
question,
interesting. So that's a demonstration of how like pipes work in Bash a bit and in your like terminal. And in Node, it's a lot of the same thing, except for there are some big differences that I won't go into today with asynchronous and non-blocking implementation. But a lot of it on the simple level is exactly the same. So everything you know from what we just saw, you can now use in Node pretty simply. In Node, the command instead of vertical bar, it's called pipe. It's actually a function. We can see how that works. I actually borrowed the example from Substack Stream Adventure, which is an excellent module you can find on NPM. And how it works is you can create a JavaScript file by running this code, touch-inout.js, or just create a JavaScript file. I actually have it here already, input-output.js is what I called it. And then you can create a simple stream by just running the code that I have there. So that's pretty interesting, and that kind of mirrors what we saw in the experiment almost exactly with Bash. So here we have, in the first one, remember we had the ls command output into the vertical bar took it and fed it into grep, and then grep finally outputted text to your screen. And here's something very similar is happening, though some different words were used. Standard in outputs to pipe. So standard in is like when you press, it's many different things, but in this example, it's when you type in text to the terminal, like when I was typing A and B and stuff, and then pressing enter, that sends that character to standard in, which then pipe takes that output, and then passes it to standard out, which is just the screen, the console, like the text that's showing up, and then it appears on your screen. So it's pretty similar to what we did before. It's just instead of using the output of like a program like ls, we were using the input and output of our terminal text. So it's pretty similar in Node, at least at the basic level. So a lot of what you know from Bash can now be ported pretty directly over to Node. So one thing that I thought was like, oh, so I can just kind of like pipe anything. I just use this, I can type anything, use this pipe command, and then it just like magically gets sent over to these other programs in Node. And that's almost true, but it's not quite true. Pipe is a function that Node provides that takes in a readable stream as its input and channels the output to a writable stream. So you can't just like pass, for example, like a string that you just made pipe it to some program. They do have to use the stream. I think Node actually provides like a stream module and some other modules that help you create different kinds of streams. There's 5 different types of streams: readable, writable, transform, duplex, and classic. And I won't go into exactly what the difference between each of them is, but they all help you do manipulate data in different ways. And that's the idea. So instead of just like, you can't, like I said, you can't just create like a string and then pipe it to something. You have to, if you want to like send text over to another program, you'd have to create your data, which would be the string, wrap it in like a readable stream, which is, you can use just various modules to construct that in different ways. And then you can send that package over to it through the pipe command over to a different program. So in the previous example, when I did process.standardin.pipe to process standard out, process.standardin returns us a readable stream that we can then use pipe on to write to process.standardout. So from like kind of a high level, and there's a lot more to be done to understand streams and be able to create your own and have them massage data in your own way. But from a high level, all you need to do is create the correct type of stream and wrap your data in it correctly. Which sounds fishy, but once you go in and actually look at like how to create a readable stream, it's actually straightforward. There's a lot of documentation on how to do that kind of thing, but you just need to create, yeah. So that's my speech. I gathered up a bunch of links that help me understand streams a little better, and hopefully it will help you all. So when I put this up on GitHub, you can check that out. Thank you.
You put it on the CyberWizard GitHub? Or?
Yeah. It's probably going to take me a day or two to change up the slides a bit more to make them probably a little bit better for someone who's just reading it out of context.
Yeah, he's cool. Yeah, coding hard is
You think there's that?
We can look at it today though.